Okay, let's look at page 1 in the packet. We are going to go over how to find mean, median, mode, and range. So, if you look at page 1, they give you a problem saying Lucia wrote the minutes she dogged on each of the 21 days on the index cards. So the first thing you always have to do with your data is order the data from least to greatest. Now, it is very easy to make mistakes while doing this. So I strongly suggest that when you do this, like I'm looking around and I've seen this data before, so I know for sure 47 is the smallest number. After I put 47, I cross it out. It's important that you do that or else it's very easy to lose track. Now I see two 55s. I see one 56. So while I'm writing these, I'd like you to write them in order. Now, notice the size that I'm writing these, so they will all fit in one line. So maybe I should have started over here, and maybe you guys can start over there. So after 56, we have 58. We have 59. And then we have 60 4 times. We have 61. We have 63. We have 64 twice. And then we have 65, 1, 2, 3, 4, 5 65s. And then I have a 68 and a 72. Okay, so now I've written them all in order from least to greatest. And it says, what is the mode? Now, mode is the number that appears most often. And there were 1, 2, 3, 4, 5 65s, so the mode is 65. Now, the mode is usually, you might think, why do they care which number appears most often? Well, if this was an election and we were voting, 65 would win. So whatever person was 65 would win. So I would say mode is used most often in circumstances like elections. Now, the median is the number in the middle of the data set. Okay, when the numbers are ordered from least to greatest, and they are. So a great way to do that is to cross out the first and the last. The first and the last. The first and the last. First, last, first, last, first, last, first, last, first, last, first, last. And 61 is the median. And the mean is the average of all the numbers. To find the mean, you add the numbers and divide by the number of data items. So, I would add all these numbers together, and then I would divide by 21, because there's 21 different numbers that I added. And you should all stop the video and try that on your own, and the mean should be 61.29. Okay, so now turn to page 4. And what we're going to go over on page 4 is a different way of displaying data. Now, if you look on page 4, this is called a line plot. A line plot uses x's. Now, a line plot is very similar to a dot plot, and a dot plot would look just like this, except instead of using x's, they would use dots. So it's really the same thing. Now, notice though, with this line plot, if you ever make one, all of these x's have to be the same height, because when they're all the same height, it's obvious to see that the mode is number 1. because it is the highest one. It's also obvious to see that most of the data is right around here. And it's obvious to see that 14 is what we call an outlier, because most of the data is here and 14 seems outside where most of the data is clustered. Okay? Now, turning to page 5, we're going to see what effect an outlier has. Now, this says the data shows Sarah's scores for the last 5 math tests: 88, 90, 55, 94, 89. So let's look at these numbers. We'll put them in order from least to greatest. 55, 88, 89, 90, 94. Now I want you to think of those 5 numbers. Is there an outlier? And obviously there is. If you got these kinds of grades, you would say, oh man, that 55 is really going to bring down my average. That's because that is an outlier. Maybe you were getting sick that day. You just didn't have a good day and you got a 55. We're going to see what kind of effect the outlier has on the different measures of central tendency. And the measures of central tendency are mean, median, and mode. Okay? So, now, here it says, what is the outlier? The outlier is 55. Let's find the mean without the outlier. So you see, I'm going to add together 88, 89, 90, 94, divided by 4, because without the outlier, that's how many numbers there are. So 361 divided by 4 is 90.25. Now, let's see what the mean was with the outlier. So I'm adding in 55, I'm going to divide by 5 because I have 5 numbers, and that's 83.2. Well, that's a 7-point difference. That's a pretty significant difference. Well, let's see if it affects the median. So here, when I look at the median, 2 numbers are in the middle. When 2 numbers are in the middle, to find the median, you add them together and divide by 2. So you actually average those 2 numbers. So without the outlier, the median's 89.5. With the outlier, the median is 89. So notice, is there much of a difference between 89 and 89.5? No, there isn't. So it does not appear as if an outlier really affects the median at all. Now, there is no mode in either case. So we learned that adding the outlier changed the mean by 7.05, and it changed the median by 0.05. And there was no mode anyway. So the median is the best thing to use to describe data when you have an outlier. And the thing that is affected mostly by your outlier is the mean.